Welcome, very good evening. Welcome to our Unacademy JEE English channel. Myself Raju, and you are watching me on JEE Live Sprint. So today's topic is chemical bonding. So in chemical bonding, most of the mains questions, advanced questions, similar models we are going to cover. Okay guys, don't miss the session. So share this link in Telegram group. Nishant is there. Nishant, share this link in Telegram. Bond length questions. This is a very structured pattern, like a digital notebook. If you type tinyurl.com/JEE mobile, you will get this digital notebook. In this, physics, chemistry, maths, different subjects, and each lecture link, video lecture, and you will get access to notes of that lecture. So physics, chemistry, maths, class 11, class 12, everything you will get on one single click. Okay, so for very quick revision, this is very useful thing. Okay guys, use it. And Unacademy subscription, highly affordable subscription. On this YouTube platform, we are giving this quality education, that too free of cost. And if you pay 60 rupees per day almost, so you will get next level preparation. Okay guys, so use this code for 10% discount. Okay, right, let us begin the session today. Chemical bonding. See the first questions. This is the first question. Here it is based on molecular forces. Okay, so in chemical bonding, the very important molecular force, dipole-dipole interaction, like van der Waals forces, right? So this is very important question. It is targeting molecular attractions, right? So let us solve this question. So it is very simple. It's a very simple question. This is your first class. Supriya, Vinod. Hi everyone. Shivendra, Divakar. Very good evening all. See, everybody should participate in this poll. It's a simple question. We are starting with very simple questions and we'll move to tough questions. Okay. Vinod, Prince Sharma, Ajit, Raju, Supriya. Right. Divakar, I told you. Yes. Biranjay Gupta, Supriya. What is your answer? Most of the students are saying correct, right? What is the answer here? Simple. Hydrogen bonding. So that is the most important topic, okay, in molecular force of attraction. So answer is simple. If you mix two ice cubes, if you press ice cubes, the forces responsible is hydrogen bonding. Okay, right. So we'll move on to the next question. See this. This question is very important. Here we are comparing hydrogen and deuterium. No hydrogen bonding strength. We can compare boiling points easily, right? Last question, most of the students got the right answer, right? So we'll see this question. Harsh, Priyanka, Abhishek. The concept you should understand, this concept. Again, what are the answers? Less than 30 seconds also you can solve. It's a simple concept. D. Right? It depends on electronegativity. So hydrogen is more electronegative. Very important point to decide hydrogen bonding strength. So now first decide this. The second statement, ODO bond is stronger than OHO. This is correct, right? Hydrogen is it. This is also correct. D2O mass is more, right? This ether What is the hybridization of central atom and what will be the bond angle? Okay. So what could be the answer for this question? Ether. So I'm writing the structure here. Oxygen. Identify the central metal atom. So this question confuses many students. Let us see how many of you will get the correct answer. Okay. So what is the answer? I'm getting answers B, C. I'm getting answers B and C. Most of the answers B. More B. See carefully. Options 106, 104, 109. Bulky group is there. Supriya. Fine. What could be the answer then? What is the answer if bulky group is present? Yes. So very few students will get it correct. Yes, very good. See, hydrogen, hydrogen, hydrogen. So there are repulsions between two methyl groups. So now you don't see lone pair repulsions. If you compare lone pair repulsions, then you will get wrong answer. In H2O you can compare. If there is no methyl group, simple hydrogens are there, we can compare that lone pair repulsions. But now methyl group repulsions. So this is going to be positive deviation, not negative. Bond angle will not decrease here. Bond angle will increase. Repulsions between methyl groups are more. Repulsions between methyl groups are more. So this increases bond angle. Okay. So bond angle is more than 109 degree 28 minutes. Right. It is not B as expected. Many of the students, okay, no? So they do this answer. They give this answer, right? 104 degree. But that is not correct here. Methyl groups, repulsions are more, bond angle increases. Right? Got it? VSEPR theory fails in this particular example. Vaibhav, VSEPR theory, so it fails in this. Okay, no? So only steric repulsions dominates. Steric repulsions. Okay, right? It is very good question because majority, I am telling you, almost 90% will mark this either A or B because bond angle less than that. But here bond angle is more than 109. Okay, right. We'll move on to the next question. See, next question also very important. Whenever in chemical bonding chapter bond angles are given, we should be very careful. You apply all the concepts. VSEPR theory you can apply, Bend's rule you can apply, steric repulsions you can apply. Okay, so all the concepts we have to keep in mind, then apply this, compare bond angles. Okay, let us start. Timer. Okay, we'll do this with timer. If we give more time also, that's a big problem here. Majority students again will do mistake. Good evening, Bushra. Fine. Okay. So what is the answer? See, again I am telling you, almost here not 90%, 95% students will fail to answer this question. Okay, 95% students, they don't get the correct answer. This is typical question. It's a typical question. See, I'm getting answers C, A. Nobody saying B and D. See, nobody in our Telegram group or any group should miss this session. Okay, so as soon as possible, what you do, share this link, YouTube link in group, so that everybody should get benefit. Okay, right? Yes, now we'll see this question. I'm getting answers A, H2O, Cl2O. The answer will surprise you and will give shock to you. Okay, yes, it will be shock to everyone. See here, oxygen, central atom, chlorine, chlorine. So now in this case, or next, hydrogen, hydrogen, fluorine, fluorine. Oxygen I'll write. This is oxygen, oxygen. Okay, see here, the first concept is steric repulsions we see. Where are the steric repulsions? In which case steric repulsions are more? There are very big atom, chlorine. Chlorine is very big atom, and there are lone pairs, lone pair repulsions also. Every chlorine has a repulsion. There are 3 lone pairs. Okay. Chlorine. Now see, chlorine repulsions dominate. So first will be Cl2O. So where is Cl2O? Only one correct option here. Cl2O is highest because we see the size. Now in this, again if you see the size factor, hydrogen and fluorine, fluorine is bigger, correct? But we should expect fluorine, correct, no? But fluorine is more electronegative. Fluorine is more electronegative. So then what we apply here? So very important thing, we apply Bend's rule. What is Bend's rule? Any idea what is Bend's rule? Bend's rule means electronegative atom occupies p orbital. Okay, so electronegative atom occupies p orbital or increases p character, or you can say like this, no, increases p character. It is atom increases p character. What is happening? Increases p character of this. If electronegative atom increases p character, what happens to the bond angle? It is s character. Here s character, here more electronegative, p character. So more s character, more bond angle. If you are not studied, no problem. Here more s character, s orbital occupies more volume compared to p, bond angle is more. Okay, yes, that is true. Here Bend's rule, simply you can remember this: electronegative atom occupies p orbital or increases p character. If it increases p character, what happens? Bond angle will decrease. So correct answer should be this Cl2O H2O. Here we compared steric repulsions. Steric repulsions. Okay na? So here these two, how we compare? Bend's rule. Okay, got it everyone? Electronegativity is proportional to nahi. It is not like that. Electronegativity atom, if more electronegative atom, it increases p character. So what happened to bond angle? It decreases. Okay, it's a very good question. Okay, so you can compare with H2O2 and H2F2, O2F2, H2O2 and O2F2. It is applicable in this also. This also you can apply the bond angle. More electronegative atom, more p character. More p character, bond angle is less. Okay, so it is applicable like this. Bend's rule is very important. Here two concepts you should understand. One is steric repulsions, one is Bend's rule. Okay, right. We'll move on to the next question. Now bond angle is over. Next, bond length. Bond length. See here. We cannot use only electronegativity difference. Bend's rule also similar, no? It is using electronegativity principle. Yes, Prince, correct. Correct. H2O2, O2F2, you can compare H2O2 bond angle is more. Right. So we'll start with this timer. So with timer we'll do. This is also very good question. Bond length comparison. Bond angle, 2 questions we discussed. Now bond length also we'll discuss 2 questions. Very good questions. Due to what Shekhar is saying, back bonding. That's what you are saying, right? Double bond character increases F2O. See, oxygen is same here and there, but fluorine electronegativity, it depends on electronegativity. Okay, right? See this question now. In this question, all terminal atoms are oxygen and the number is also same. 4 oxygens. All containing 4 oxygens. Harsh, because already we are using Bend's rule, it is based on that only. Okay. See, what is the answer for this? What is the answer? You give the answer for this. What will be the correct answer? Nobody is giving more answers. What will be the correct answer for this? 1 minute over. Sajal is saying A. Satya is saying A. Are you sure? It is bond length. Bond length A. I am getting A. Answer A. B. A. C. B. A. B. C. A. Fine. B. Okay. Getting C answer. D also I am getting. So no clarity at all. So many students, what concept you are using is, what concept you should use? Silicon, phosphorus, sulfur, chlorine, all atoms, all the terminal atoms are same. All atoms contain attached to 4 oxygens. Okay. So what concept we should use? All produces resonance. All have resonance structures. Okay, bond strength we have to compare, only bond strength. So silicon, phosphorus, sulfur, chlorine. So they are in the same period, right? They are in the same period or not? So within the period, what will happen? Atomic charge, nuclear charge, effective nuclear charge. Effective nuclear charge increases. Effective nuclear charge increases. So what happens to d pi p pi orbitals, right? It is the pi bond formed is d pi p pi. D pi p pi. That means it's a pi bond formed from d orbital of central atom, p orbital of oxygen. D pi p pi bond strength increases. That means SiO, phosphorus, oxygen, sulfur, oxygen, chlorine, oxygen. So where is the more bond strength? Silicon to chlorine, bond strength is increasing. Okay, bond strength is increasing. Bond strength here increases. So silicon oxygen bond is less stronger. Chlorine oxygen is more stronger. Understood this point? So if you know bond strength, bond length inversely related to bond length. Correct? So SiO bond strength is very less, bond length should be more. Correct? No? Everybody got the concept, right? Bond strength, bond length are inversely related. So silicon oxygen bond strength is less, so bond length should be more. Okay, fine. We'll move on to the next question. Right. This question. So there are 4 molecules or ions are given which have all their bond lengths are identical except which compound? That means in 3 compounds bond lengths are same, but in 1 compound bond lengths are not same. Okay, now you have to find out that compound. Let us start the timer. So I want to see more and more students here. Okay, share this. Don't forget, share this link so that everybody should get benefit. Okay. Right. What is the answer for this? 3 molecules or 3 ions have same bond length, but 1 compound there are different bond lengths. So what is that? B, correct. Okay. Shivendra is saying B. Any other answers? C. Getting answers B, C. Right. See here. What are your answers? B, C. I am getting A also. ASF3. ASF4 minus. Okay. C will first we'll draw the structures a simple way. ASF3. What is hybridization? Hybridization is sp3. ASF3. So sp3 hybridization, and it is pyramidal. Correct? It's a pyramid shape. So all have same bond length. AS and F. Bond length is same. Now this second example. What is hybridization? What is hybridization here? Acha, now everybody is saying D. bond lengths are identical. Read the question. Except, that means 3 molecules are same bond length in that molecule, but except in one molecule different bond lengths, right? So pyramidal geometry, AS so what is the geometry here? sp3d plus 1 lone pair, correct? AsF4 minus sp3d plus 1 lone pair. So what is the geometry here? Seesaw structure. Now see here, this bond length is different axial bond length compared to equatorial. This is equatorial, this is axial. These two bond lengths are different. Remaining all cases we get same bond length. AsF4 plus, so what we get here? As plus F, it is tetrahedral. All bond lengths are same. No axial, no equatorial. It is octahedral. AsF6 minus As minus F6. All have same bond lengths. Here sp3 hybridization, here sp3d2. Okay. So except in this, remaining all compounds have equal bond lengths. Okay. So this is the correct answer, B. Axial is always more than equatorial. That is very good. Okay. Right. Let's move on to the next question. Again bond length. So bond length question only. Where in which of the following all bond lengths are not equal? Okay, so let's see this question with timer. With timer only will do. Okay, fine. Yes, the same concept you can apply here. If axial equatorial comes, definitely different bond lengths. So where are we getting axial equatorial bonds? Here number, how many molecules? How many molecules? Bond lengths are not equal. Number we need. Aryan Sharma, hi. Late. Okay. Right. So what are your answers? What are your answers? 4 I'm getting answer. CLF3, PCL5. Number I need. Number. How many molecules are ions? Bond lengths are not equal. SF5. How many? 3, 4, 3. It's a numerical type, no? How many number we need? Achha, majority you are saying 3, only 3. Not equal. Wrong. Should try again. Only 3 we don't get. We get more than 3 definitely. More than 3 means 4 only. Okay, let us see. So here hybridization you see sp3d. So axial equatorial is there here. So different bond lengths. So PCl5 different bond lengths. Axial is always more than equatorial. SF4 sp3d. Axial is more than equatorial. CLF3 again sp3d. Okay, axial equatorial are present. XeF2 sp3d plus 3 lone pairs. So there is no axial equatorial here. No axial equatorial. All bond lengths are same. Here we got this, we got, so same sp3d. So this is also sp3d. sp3d. O3. O3 we have a resonance, resonating structures, right? So all the bond lengths are same or different? O3 same, P4 same. O3 resonance, P4 all are single bonds, the same. Bond lengths are same in 3 molecules, and remaining molecules bond lengths are not equal. Okay, so here what is our answer? 1, 2, 3, 4, 5, 6. So in 6 compounds, 6 compounds, bond lengths are not equal. Bond lengths are not equal. Got it? O3 same. Any doubts here? No doubts, right? Everybody is getting 6. Okay. So then we'll move on to the next question. You answered first. Great. Okay. Right. So next this one. Here bond lengths we compared, bond angles we compared. Now let us move on to bond strength. See here, sequence wise topics I have taken, and sequence wise we are doing questions. So bond length question comes, what are the concepts you have to apply, we discussed. Bond angle, we discussed different concept. Now bond strength. Okay, let us see this question with timer. So where bond strength is more, because heat of dissociation is minimum. Where bond strength is less, because heat of dissociation directly related to bond strength. Okay, let us see. Minimum heat of dissociation. See all the options. If bond is stronger, maximum. Bond is weaker, then minimum heat of dissociation. Getting the answer D. Okay, any more should participate in this poll. D. Purna is saying A, Mahir is saying D. Right. Answers. Shivendra said D. Sajal D. D. Let us see whose answer is correct now. D hoga pakka. D. Right. So majority answers are D. So D is correct or not, we'll see. Okay. This is basically back bonding, correct? Nitrogen, it is coordinate bond. Nitrogen is giving lone pair electrons, boron is accepting electron pair. So it is coordinate bond. Where coordinate bond is stronger? See, if methyl groups are there, then at experience repulsions. Okay, see 3 methyl groups, only 2, only 1, 0 methyl group. So more methyl groups, more steric repulsions. So because of steric repulsions, so boron nitrogen bond is weak in this compound. Trimethyl, there are 3 methyl groups, more repulsions, and boron also has 3 methyl groups. Okay, so only this bond is weaker, so minimum heat of dissociation. Okay, right. So let's move on to resonating structures contribution. Okay, so let's start the timer. This is easy question only, but little bit tricky. So there are some rules to compare the resonance contribution. Okay. See this question. SCN minus 1, clearly visible, right? S minus Cn, S plus 1, N minus 2. The charges you should see clearly. No, Satya, it's wrong. Unstable means bond is not strong, so minimum dissociation. Okay, na? If bond is weaker, then minimum dissociation. That way we have to convey that. Okay. For this question, D cannot be predicted. No, not possible. We can predict. There are rules. Yes, I'm getting D answer. B. Durgesh saying B. Let's see who's correct. You're not giving answers. Ashish is giving C. I'm expecting answer from everybody. If it is right or wrong, you first type it. Let us see the correct answer. C. Majority they are saying C. Are you sure C? That means, see here, the basic rules. What are basic rules? Formal charges should be very less, then it is more stable. Okay, na? See, formal charge, least formal charge. The first rule in this 3 comparison. Okay, na? So where is the least formal charge? Formal charges. X and Y, minus 1, minus 1. But Z has 2 charges, minus 2 plus 1. So Z is least stable. So where Z is least stable, only one option here. Z should be least stable, more charges. More charges, least stable. Less charges, more stable. Now X and Y we compare. X and Y we compare. Okay. So in X and Y, nitrogen has negative charge, sulfur has negative charge. Okay. So generally what we think, electronegative atom is nitrogen. Nitrogen negative charge should be more stable. Sulfur also electronegative, but less electronegative than nitrogen. But what is favoring here is sulfur size. So size factor dominates compared to electronegativity. Or with one single concept, you can eliminate all other options. Z should be least stable. Anyways, Z should be least stable. In X and Y only you should have doubt. So X and Y, more size, and it is also electronegative. It can stabilize minus charge. Okay, size factor dominates compared to electronegative. So S minus stable compared to N minus. Okay, so Y first, S minus is there, next X, least is Z. Who is asking? Kush Rathod. I've taken your name. Okay, happy? Prateek, I've taken your name. Okay, now you participate in the poll, focus on subject only. Okay, Right. So this question very easy. It's a very easy question. Okay. Very simple question. Which of the following species have banana bonds? You're right. Very good. Satya Prabha, you're right. Where banana bonds are present? It's a very simple question. Very, very simple question. What is the answer for this? Banana bonds, 3-centered, 2-electron bonds. 3-centered, 2-electron bonds. See? Okay? Right. So banana bonds present only in this. Here just back bond. Here 3-centered, 4-electron bonds. They are not banana bonds. They are bridged bonds, no doubt. But banana bonds means 3-centered, 2-electron bonds. Achha, see, I am not asking bridged bond. This has bridged bond. This has bridged bond. Every bridged bond cannot be banana bond. So students, some students, at least 60 to 70% will get confused. See, that's why I have chosen this question. Very simple. 3-centered, 2-electron bond is present. This is banana bond. Okay, na? These are just bridged bonds, but not banana bonds. Okay. Yes, only A, not C and D. Make structure of option C and D. It is very simple. Option C and D. Okay, this is a structure. Similar way you can write for beryllium also. Beryllium polymer also you can write similar way. 3-centered, 4-electron bond. Fine. Mahir. Fine, right? I made the structure. Similar way, beryllium aluminum place, you write beryllium. So BeCl2n. It is a polymer structure. Okay, fine. We'll move on to the next question. This question. This question is easy. It's an easy question. Dipole moment question. How many compounds shows zero dipole moment? Let's start the timer. Okay, how many compounds have zero dipole moment? So simple vector addition if you do, then you will easily get some physics concept you require. How many compounds shows zero dipole moment? Getting answers 4, 3, 5. Which one is correct? Okay, so 4 B C D E. Okay, fine, let's see. So here first there should not be any confusion here. Here dipole moment is not 0 because oxygen hybridization is sp3. This is not a linear, it's angular, right? It is not 0. Here it is 0. 120 degree vector addition, very simple. Okay, so this is 180 degree vector addition, exactly opposite, and magnitude is same here. 180 this vectors will cancel, 0. Here trans, this is also 0, but here cis, this is not equal to 0. Okay, so how many we are getting? Total 1 2 3 and 4. So total 4 molecules, dipole moment is 0. Yes, 4 has 0 dipole moment, fine. Okay, understood? Most of the students got this, right? We'll move on to the next question. In dipole moment only, from dipole moment, how do we calculate ionic character? So very simple, but with time we'll do. Okay, with time we'll do. BCDE. What BCDE? Correct only, no? Correct, BCDE, correct. Biranjay, it is correct. All 4. Very good. Now see this. Solve this with timer. You might know the formula, but try this with timer. Actually, you're boring. It's like a boring session. Okay. Means you are not involving in the session. These many questions we are doing here. Okay. See. Observe dipole moment by theoretical dipole moment. Theoretical dipole moment into 100. Okay, so that is called percentage of ionic character. Okay, so observed dipole moment is given. So dipole moment is 1.8 into 10 power minus 29. Okay, so that is given 1.8 into 10 power minus 29. So theory, the bond length is given 150 picometer. Okay, so 150 picometer is distance. What is the charge? 1.6 into 10 power minus 19 into 150 into 10 power minus 12. So simple numbers only. So you will get 1.8 by 2.4. So into 100. So this is 75%. Okay, 75% you should get. So easy calculation only. 6364, 3 by 4. Okay, so 3 by 4 is 0.75 into 100. Right, so this question or this question will do. Okay, last question. This question will do, and this is the last question. Which of the following overlaps are incorrect? Okay, which of the following overlaps? No, it is not 60%. The previous question 75%. 3 by 4 easily coming, no? 1.8 by 2.4. 3 by 4. Okay, so this question is very important. How atomic orbitals are overlapping. This is the last question. We'll finish this session. Last question. No problem. Calculation mistake. New Year, Shivam, welcome. See, assume x-axis is internuclear axis. The x-axis is like this. Now it is internuclear axis. Okay. See, multiple correct. It is multiple correct. Multiple correct. Okay. Options can be both also. See here. So internuclear axis, if the overlapping through internuclear axis, sigma bond is formed. Okay. So through axis, sigma bond, perpendicular to axis, pi bond. So this, is it correct? See, B and D. That means here this A, B, C, D, E, F. Okay. So BD, you can see BD and CE. C and E. Okay. C and E, B and D. So PZ and PZ, this should form pi bond. Okay. S cannot form pi bond, right? S can form only sigma, right? 2px, it is through internuclear axis, it should form sigma. 2py, 2pz, combination is not possible. Either 2py can combine with 2py, 2pz can combine with 2pz. Okay. So B and D, C and D. Fine. So with this, we finish today's session. And if you have not connected with us till now, what you can do is, you can visit our Instagram page. You can tag us at @Unacademy JEE official, or one more simple thing, you can download Telegram app and go to browser. If you type tinyurl.com/JEE live chat, so that you can get connected with us, you will get notifications. And see here on this group, almost 30,000, more than 30,000 members are already there, IIT aspirants. Okay, so you will get notifications, you will get DPPs, you can ask whatever query you have. Okay, right. And it is a digital book. If you type tinyurl.com/JEE mobile, you will get directed to a digital notebook. So it is very useful for quick revision. You can study physics of class 11th, chemistry, maths, or class 12th subjects. Lecture video is available, and you will get access to notes of that particular lecture also. And Unacademy subscription, highly affordable. What you will get is live plus classes, and that are more interactive. And in every class, a doubt session. So educator will give poll. In that poll, you can see here, topper respective, what is your score, and topper, in what time he is doing or she is doing. So topper respective, what is your time, everything you will get to know. And there are leaderboards are available after the session, who is performing better, whether you are in top 10 or not. So everything you will get to know, instant evaluation. Okay. Test series are going on for April 2020 attempt. Okay, so don't miss that. You can subscribe Unacademy, and 60+ educators are teaching on this platform. And one subscription, you can get access to all the different courses. That means you are not joining any batch here. With one subscription, you can join any number of batches. Okay, right. In the doubt session, you can take a picture of doubt and you can post it. The doubt will be cleared in that particular class only. Okay. How to get the subscription? Download app, install it, go to plus and choose your goal, get subscription. So total payment options you will get, and you can see here the payment options. So if you take for 24 months, it is just 1,500 per month. The prices are decreased. you can see here 1500 per month only. If you opt for 24 months, 12 months, it is 2500 per month. So highly affordable, guys. So don't miss this opportunity. If you like the session, use my code Raju10, you will get 10% discount. And don't forget to subscribe our channel. So hit the red bell icon. After this class, you will get PDF notes also. Okay. Unacademy JEE English, and there are other channels too. Unacademy NEET, Unacademy Foundation. So every channel is very beneficial and very important for competitive examinations, and you can share this with relatives and friends. And on this very big platform, you are getting quality education, that too free of cost. Okay guys, let's crack it. So we will crack it, and for the next subscription, use this Raju10 code for 10% discount. Okay, so we'll meet in the next session. See you, take care.